We have here a dictionary. We want to searching for words. Starts with K's, and we're just flipping pages until to reach K's pages. For doing that, we need a lot of times to reach to K's. And you know, the dictionaries, it has a lot of pages, maybe over 1,000 pages. We have another method to doing that, is to split the dictionary into two pieces, M pages. M small paper just for identify the pages. Okay, and I want to reach to K. For that, we know the ABC. We have a left and right hand side, and we're working on left because the K between the A and M. We split again. We have a D. We have a D, and then split. We want to split, and you know, we have right and we have a left and right hand side and thing, and we know the pages, the K between the D and M. And then we have a G. We add the small paper, and then we know the G and M between them, the keys. And we have here, after split another time, I, and add the small paper again, and we have this small spreadsheet or pages, and split it, and we have I, and just split it again, and you will see the K pages. You see, we have here and reach to the K pages. In this part, we're gonna show you the difference exactly between the simple search and a binary search. Okay, let's doing this visualization and see what happened. You will see the binary search moving faster than simple search. You see, the simple search is very slowly compared with the binary search. And we can do an inspect element and go to console. You will see the binary search takes a 0.03 millisecond or second, and the binary search need for 32.7. You see, the difference is significant. Okay, this is for binary search, but before that, I will just doing a trick here. I will add the script trying to 100 and see what's happening again. This work very well. Okay, start. You'll see it doesn't see the difference between them. That means the simple search is faster or the same as the binary search. No, actually if you want to test the actual speed, you need the bigger value. Like if I add a million to them and doing refresh again, you will see the binary search more faster than the sample search. This value of them, the sample search takes 5.9 and the binary search takes a 0.02. That means the simple search is slower than the binary search when you're adding a bigger value. If you wanted to test any algorithm, you need to add a bigger value to see what's happening. And in the smaller value, it doesn't matter if you're working on 100 sets or 100 recording in database or 1000. But if you're working with the 10,000, million, 2 millions, billions, you need here the speed. For that, we have seen the binary search work very well with the million, or work with the big recorders, as we say in this code. And this code in description below, GitHub. You can download easily and play around it. We implement binary search with Python. This is our steps for doing that. Let's take 8 steps and do it in programming languages or in Python. First of all, create a function has a 2 parameters list. I will define the functions, call that binary search, and then add a list, add item parameter, 2 parameters, and then create 2 variables called low. The first of low is equal 0 and high equal the length of the list -1, and I will explain why that. Okay, number 3, while loop, and say if the low is smaller and equal high, doing something. What should you do? Get med or create med functions. What is a med functions? Abbreviation of median, and it is low plus high divided by 2, and then create a target variables, have the list of med, and then say if the target equal the item, return if you want target. Okay, if a target greater than item, I will add, or I will say high equal med -1, otherwise low equal med +1. Just okay, and if the while loop it is finished without anything, just return unknown. I want to test this. Okay, now CSLS and to cd and Python. Before that I need to call the functions. Call the function binary search and add the list that you want search for, like 2, 3, 4, 5, 6, 7, and 8, and 9. And you should be in order. You should be sorted array. And the target, like I want to looking for a lookup for 7. I will add 7. And then run binary search. Let's see what's happening. That is the point, or the first error, because sometimes when you add low plus high and divide it by 2, it give us the floating numbers, not integers numbers. For doing that, we will just make a integers function and then run again and see this work well, but it doesn't print anything. For that I will make variables like called a maybe and print a. Let's see what's happening again. And we have a 7. That means we have a 7 in this array. And if change it to any number does it find in the array and run, you will see none, because this number it doesn't found in this array. We can add like 8 and see what's happening. 8. This is a binary search implementation. But before we're going into a simple search, you need to know something. First of all, you need to search, or you need to explain what is happening here. Okay, first of all, low. I will explain that. Why are we made a high length list -1? Okay, we know the index in the programming languages, like if you have A, P, C, and Z. If you working as an index, you will see like 0, 1, 2, and 3. Not 1, 2, 3, 4. It is 0, 1, 2, 3. And if I want to low, we know that this is low. And if I want to reach the high, that I mean it will be a 3, not 4. For that, you will get the length. The length here is like 4, and -1, it is equal 3. This is why our subtracting with subtract -1. Implementing a simple search. It's a straightforward function. First of all, I will define a function called a simple search. Okay, has 2 parameters. First, list item, and then making a small loop or for loop for the list, like I and west, and I want to make a range. For that range list, okay, and then say if I or list I equal item, just print or return item, okay, and doing that until return false, return none, and call this function sample search and add the list 3, 4, 5, 6, 7, or 8, 7, and 8, and the target or our target or items that looking for like 5, and save and run this command, run this python simple search, and before that I need actually to add in variables and print this out and see integers no, there's a problem here. The 4 are, oh yeah, I'm so sorry that because I need to add a length for here and working very well, okay, and see what is happening. It is a 5 here. What if I say 2? It's worked fine. And what if I say 1? It is none because it doesn't found in this index, okay. That is a simple search. It's maybe quite easy than the binary search, but it is slower than the binary search. Binary search is more faster than a simple search.